Hi, everybody. Our speaker today is Dr. Leslie Elliott, a former Shell Canada exploration geologist with a PhD from Dalhousie University. His talk today is titled Reefs by the Roadside, a preliminary guide to easily accessible Canadian fossil reef localities. His talk provides an overview of fossil reefs through time and highlights accessible Canadian sites often overlooked in geological roadside guides. Please join me in welcoming Dr. Les Elliott.
I was going to tell you to go to the next slide and then you would have had an illustrated introduction to me. That's what I was just finishing my MSc. I actually have a 9-month MSc in palynology, and that was my end of my palynological career. And I don't know, this is 1 year after I went and got my MSc, and that's Philippolynides up above the tree trunk. And I went back to my locality that is underneath the entrance conglomerate, which I was trying to date. And there was this tree stump. And I don't know if I was looking so hard, polynomorphs, which is just sampling bags, and you look at it later after putting hydrochloric acid and whatnot. And that was there, and I missed it, or it eroded over the winter, and I came back to it. Anyway, so I started off as a palynologist, sort of, with Dr. Selk. But I soon saw the light and started worrying about fossil reefs for Shell Canada for 30 years. What I'm going to talk to you about is based a lot on this book right here, and usually get something for giving a talk, and I'm going to give you something for giving a talk, and you'll get this book to add to your library. And if you have smartphones and you actually try to go to some of these places that you could read about in the 4th edition of last year's bulletin, just take a picture of whatever the number is that you can find in your write-up, and you'll have a lot more details than what I gave in that article. So anyway, Dr. Stokes said never retire, so that's why I'm still here 80 years later. But anyway, and that's when I was 20 years after I got my MSc in palynology. I was on I tried to get that as a modern example of a reef. It's actually Gill Springs, and it's the tufa or travertine deposit, but I'll show you later on that it actually has lots of interesting fossils in it. You'll notice I've got the source for Bible, and that's what that book is all about. It's one that came out of a conference, or actually a whole effort by everybody who was interested in fossil reefs in Canada back in the late 1980s. So anyway, so that's the background. Hardly anybody came to my poster, so I felt kind of bad. And then I did finally get this thing written, so you can read all about this stuff. And Howard Allen put in better pictures than I had, but you'll get to see what you would have had to look at in the write-up a little later on. So reefs have all kinds of definitions. In fact, that's one of the things that, like all geology, you get 2 or 3 geologists who'll get 5 or 6 ideas and they'll argue about them. And one of the definitions by one of the fellows that I respect, he had divided as reefs are calcareous deposits created by essentially in-place sessile organisms, so they kind of get attached to stuff and stay there, which this little guy is Tyndallstone, and that's a mollusk, and that's a tabular coral. And that's the start of a reef. And in fact, at that particular time in the late Ordovician, in the middle Ordovician, reefs got started again. But anyway, that's how small they can be. Or I actually got my PhD worrying about offshore Jurassic age reefs. And in the core, I had a reef complex, and then I had a catch reef, which must have died when it was alive because the coralites never even got killed. They got killed later on. So something organic was in there that kept things out of it. Anyway, so they go on that side, or if you get down to New Mexico, West Texas, you'll want to go to the Carlsbad Caverns, and that's El Capitan, the highest mountain in Texas, but it's also the reef edge of a Permian reef. In Canada, you have to go way up north to see a Permian reef. So that's the reef by the roadside, that's mountain sized, and that's a reef that's core sized. There was a time, about 3 billion years worth of time, that reefs were all microbial, or pretty much all microbial. There's stromatolites and thrombolites and other kinds of things. And some of the algae started, like red algae, go way back. They're one of the oldest of the algae. But that's all that made reefs. But they did make shelf edge reefs. they more or less, if you look at this trace of how common they were, they get replaced by particularly corals and by sponges, and stromatoporids are kind of sponges. And so you hear about stromatoporids and Paleozoic reefs a lot, but they're basically sponges and corals nowadays are what make up the classic or main frame builders of reefs. And even deep water reefs tend to be either corals or sponges. So they come and go through time. So we can talk a little bit about that. What was interesting is the sponges actually made a good effort at making pretty nice looking reefs called the archaeocyapid creature. Anyway, and then they died out. We went back to the Cambrian style of stromatolites and thrombolites and not very much of the multi-celled animals and plants. And there are some peaks, and the reason we don't pay sales tax in Alberta is we have a lot of Devonian reefs, which was the acme of Paleozoic, the highest, and the next highest is the Silurian reefs. And you can see the little bulk outs for the reefs and the stromatoporids. And they did a pretty good job in the Jurassic, late Jurassic, and that was what I enjoyed looking at for quite a while. And nowadays, again, it's another acme of corals and stromatoporids, but there's times when they're not around. Instead, you have something called roost, which is a type of clam. Some of the clams are bigger than this table, and they look are big as a garbage can. They seem to have displaced most of the corals because they backed off a little bit. We'll come back to chart something like that, but there was sort of a try at being reefs, and that we sort of know and love with sponges, and they die off and go back to the old microbialite story. And then you're back to the acme or highest amount of reefs in the Paleozoic, which are late Devonian, but not the latest Devonian. And then Jurassic reefs, and then modern ones, so sort of 4 phases of reefing. And sometimes when you have made a die-off of all kinds of creatures, that also gets rid of the corals and the stromatoporids. They don't get rid of them completely because they obviously start up again slightly differently. But so these major die-offs, sometimes they didn't make much difference to the reefs that were going already, but that made a lot of difference to the dinosaurs. And you can see this old slide that has tertiary instead of, in fact, if some of you were here 20 years ago, you probably would have seen this slide or something like it. So corals and sponges. Here's another definition. In fact, Noel James, who was sort of Mr. Reef for Canada, and Pierre-Henri Bourque, but they had reef terminology. One of the delights of geology. And like I said, if you want to get an argument, you can talk about, in fact, I tried to get petrified beaver dams into Reefs of Canada. And even though I was one of the conveners, they wouldn't let me do it. They let me do a lot of other things, but not that. Those folks sort of talked about reefs, which are sort of corals and sponges, then mounds, which can have corals and sponges in them, but in fact, they tend to have smaller things, and they often are in weird positions, especially in either deeper water or water, saline water, and so on. Ideally, of course, you like to be in tropical or subtropical type temperatures, and you like to be in normal marine waters. Although the guys in the Persian Gulf, maybe we'll have to transfer them. They can stand more salty water, so we keep on messing up our reefs with too hot of water. You'll maybe have to inoculate them or move some of the ones in the Persian Gulf because they don't mind hot water. Anyway, here's an example of you get atolls, you get fringing or barrier reefs. This is the second largest reef pattern in the modern world after the Great Barrier Reef in Australia. You can get fringing reefs, although not so much in there, but some of the islands further south have them. And there's a modern reef, and we know about whitings and kill-offs of coral due to either high temperatures or sometimes nutrients. Corals especially are kind of adapted, the modern ones anyway, to being in nutrient poor or not great nutrient, they call them ligotrophic conditions. Sponges, well, if they can get small sized things to eat, they don't care where they live, and they can even live in shaly conditions. This is a more, the other one is qualitative, it's more quantitative. There actually was in 2002, we had a reef symposium, a reef group that tried to talk about Canadian reefs in 1968, and it may have inspired the 2002 thing, which went all over the world and tried to get reef experts to contribute to the conveners. And they ended up being able to come up with actual numbers of reefs. And so if you look through this, The dark blue are the microbial type things. So that's the kind of thing that was in the Paleozoic, but notice how they come back in the lower part of the upper and middle Cambrian. And sometimes they come back even in the Permian and Carboniferous. In fact, if any of you are petroleum geologists, you know that if you want to find reefs, you look in the Devonian, and if you don't want to find reefs, you look in the Mississippian, and you find a lot of neat fossils in the Mississippian, but you don't seem to find, you find corals even, but they don't seem to make the kind of reefs. And it may be where you are, because if you go to Russia, there's a huge reef that is, I think, Carboniferous in age. Esso and Chevron are probably unhappy that the world has gone the way it has, because I guess they're kind of missing out on that. Anyway, and then you get algae in the green, and you can see that what has happened over time is there are peaks when you have a lot of microbialites, and those are the same times when you have a lot of oolites. So what it means, to my mind, is a clam can make himself a nice shell in any kind of water, organically, and if he thinks it might dissolve, he might even put an outer coating like Mytilus does. But anyway, for microbes and oolites, which are inorganic, although there are microbes in it, but there's probably microbes in everything, including in us. But anyway, you can see these match. The peaks match and when you get a ragonitic type of corals, which is what starts in the start of the tertiary, and that's the kind we have now, the scleractinian corals are made of aragonite, the oolites actually coincide. Kind of interesting how that pattern changed. You can see that there are times when it's good for reefing and times when it's good for microbialites and oolites, and sometimes they alternate and sometimes they coincide. The last time you actually see a lot of microbial material, and in my working on Jurassic reefs down the slope, that's what you get, microbial stuff on the slope. I think that's as much as I want to say, except that this is sort of a pattern that the fellows who wrote the Kite Kisling and Friends talked about different peaks, and this is sort of the first time of metazoan or complex animals. That's the sponges. They all die back, and you start getting microbialites turning back into the Precambrian type of situation. And in the middle Ordovician, you start getting different kinds. We thought huge numbers of them, but they start again, and you start get corals and sponges or stromatoporites in them and other things along that line. And then you have a bit of a penultimate peak in the Silurian of reefing. And then the Paleozoic reef, which is the Devonian one that, like I said, save us from sales taxes. During the Carboniferous in Pennsylvania, it's kind of hard to know what's going on. It's not a great time for the corals or sponges, but it seems like a good time. There's a lot of platyalgae that make mounds and so on, and you can see them in there. So this is kind of weird reefs in time, and this is the start of arachnidic reefs, and there's a couple of peaks, the late Jurassic one being one of the highest, and of course the modern ones. So why did I get into worrying about reefs by the roadside? There's this really good guide, and there's guides right there that you can look at for visiting geological sites. And being a person who kind of likes reefs, maybe too much, but there seemed to be a lack of them in the guidebooks. And this is one place where they didn't say, except in one, I thought they didn't say anything at all, but in fact, Martha Hickman, unfortunately, Hickman Hill, she's died of cancer recently. I just thought she's going to work her way right across Canada, because if you ever get to the Maritime, she started with her first book on Newfoundland, and it's a great guide, and it has a lot of some examples of, in fact, you'll see some of the ones that she has in Newfoundland of reefs. And then she went and got together with Sandra Barr and wrote a real good guide on the geology of and interesting stops that are scenic and so on. And this was one of her stops 14. Her main point of that was see all these lovely looking colorful rocks. I know if you're a petrographer or if you're a rock collector, unfortunately, sedimentary rocks are usually not very exciting, except maybe red beds, but then they don't tend to have fossils in them, so then you don't like them again. But if you like colorful, lovely rocks, you want to go into metamorphic and igneous rocks. And that's what she wrote about. So she basically had the Ice Age hitchhikers, and that is the plateau that all that stuff was eroded off by the glaciers and then winnowed. And you have blocks, boulders that are bigger than this table. If in fact, if you want a good picture downward, you climb on top of the rock and take pictures downward of what's going around. But the rocks that they were on top of are all these dolomites, carbonate rocks, and they go all the way from here, this one patch, and they go all the way back to somewhere in there. It's either an algal reef, and you can get back to algal or microbial reefs by having very saline conditions or having weird kinds of water, like in Lake Van in eastern Turkey. They have microbial mounds that are huge, but they're because the water is very soft water or non-acidic, and they're not typical ocean water, and there they are. Anyway, so I got all excited, and I actually did quite a bit of fiddling around with this. And then when I decided to move back to Alberta, I guess it's going to be a job that never gets finished unless somebody can get keen on it. But there are good publications on it, and one of the but we'll get back to that later. There's what they look like, and to me, I'll show you a modern example that makes me think. There's some folks that think microbial, and there's other folks that think, in fact, Paul Schenk in 2001, and after about 3 years worth of work, decided that they in fact might be seep deposits. And we didn't know what seep deposits were until 1977. And if you know black smokers on the mid-oceanic ridge, and that's a hot example of a seep deposit. But if you go to Yellowstone, that's a hydrothermal seep deposit. And I bet you if you look made thin section, you probably could find microbes in it because you can find them everywhere. But they're mainly inorganic and coming out of the water when you get rid of the carbon dioxide. It's helping dissolve them up at the surface. That got me all interested, and you can see they are layered and so on. And there's a few places where I've worked with dolomite a lot because that's what tends to be reservoirs in the Devonian reefs, the best reservoirs. So you have to kind of imagine what those molds and shapes are, and some of them look like shells. And so I saw something that looked like that, but whether they are or not, that's one of the things you can keep on arguing about. You can see the pattern of that's a quarter or some kind of coin, so that's pretty small scale example stromatolite, and there's a pattern something like that or something like that. But those things, that's 1.5 meters, so those are pretty large scale. And you think, well, could that still be well, if you go to a lake that again, funny water, and you have lovely looking, pretty good analog. And that's one of the things you do in geology is you look at the modern and try and sort of imagine what would it look like preserved in the rock record and very old. On the other hand, you can go to, and this I think is from Yellowstone, and you get travertine deposits, and they can have layering. So I think I gave you a talk, and I said, I wonder if there's stromatolites on Mars. And I showed you that from the satellite, they could find that they look like it's calcite or calcium rich, and it's right on the shoreline. It's exactly where you'd expect to find stromatolite. I don't think the little critter or the little machine has got up to that level yet, but I'm waiting to see if they are layered or not. And even if they are layered, there'll be a question about whether they are a seep deposit, a hot or cold seep, or something to do with microbes and life. So I said, well, there's a real good guide, and they didn't make the point. In fact, they have a picture of that thing, but they have it at another stop where they're on top of a salt dome. And she says, over there, you can actually see a reef. So anyway, they didn't miss it, but they didn't make a big enough deal about it, in my opinion. But she did make a big deal about, as I said, if you take a holiday in Newfoundland and you want to make a lot of interesting geological stops, get her guidebook and look at some of the stops I have there. Some of the stops, they're actually the Ordovician Cambrian boundary, the gold spike that they always take the lowest level change. That's on the Isle of Newfoundland. And the Cambrian, Precambrian boundary is also on Newfoundland. In fact, they've got a bunch of Chinese names for the, they say how to get rid of old geologists is you change the names of the formations. And that's the truth. I don't know anything. I used to be pretty good at it because in Quebec, that's the age your localities old. However, there is a Terranuvian, which means Newfoundland. So the oldest unit that has a golden spike on it, and the lower part of the early Cambrian is actually got Canadian name, and so that's kind of fun. But what is interesting is on the Isle of Newfoundland, this is one of her stops. It's Flowers Cove, and there's Flowers Cove in the background, little hamlet, and they've got walkways and guides, and they've got quite the tour stop for you, and it's really great to go there. What is interesting is, I'm not sure, but these things almost look like they're intertidal now, or at least maybe slightly above intertidal. I don't know what the tidal range is in here, but they probably grew intertidally like they do in Shark Bay. And so it's now exposed, you can walk on it, except it's 450 million years or whatever the middle Cambrian was in Newfoundland at that time. If you don't want to go that far and you're just driving around and you're heading towards Alberta on the Yellowstone Highway, Yellowhead, I guess, not Yellowstone. That is, all those light colored things are Cambrian. They're the youngest Cambrian, the Ediacaran, so the end of the Cambrian, and they're full of stromatolites and pisolites. And if in the right place, the Ediacaran actually has a soft-bodied creatures that, in fact, were metazoans of some kind. In other words, multi-celled animals or plants. And in some areas, I don't know if you're about right here, but in some areas in Western Canada, you can actually find organisms, whether those particular things aren't necessarily making a reef, but that whole thing is a reef platform, and then you have siliciclastics above it. So from all the way from the furthest west you can get in Canada province-wise, or furthest east and furthest west, you can find roadside stops. And if you want to look at the first try at being a reef with sponges, these are the archaeocyathids, this guy here. You can look at it, and I don't know if I thought it was the tallest lighthouse, but apparently the tallest lighthouse in Canada is actually on the Great Lakes. But it's a very tall lighthouse. Walk up, take a look at the view. You can see where a British cruiser actually tried to get out of the way of the iceberg, but got in the way of the shoreline. So it was very embarrassing for the British Navy. I think the captain lost his job. But anyway, so there's all kinds of history around there, but this is an interesting piece of history for reef formation. This is the archaeocyatid reefs, the first try being reefs, and then I don't know what went wrong. It's kind of like buying the latest car that comes off the assembly line, and you should always buy the second year after when they figured all of the bugs. But something bad happened to those guys. But they certainly look like sponges, hollow and double-walled and so on. That second try, after you've gone back to Paleozoic-style microbial type things, is the Shazy Formation, which is Middle Ordovician, and then you start getting small reefs with sponges, with corals, with all kinds of additional side creatures living in there. And as I say, there's that little guy, by this, the late Ordovician. I don't know of any really wonderful big reefs, except maybe on Anticosti Island, that you can get into Ordovician reefs. But you have to take a boat, and then I guess you can be by the roadside, but it's a little, I didn't count it. Sort of the second highest or most common, I don't know how many of you, is there any guys who are petroleum geologists worried about carbonate reefs? Mind you, I'm the only one. Takeo knows. There, we got a couple of them. Except for the Amphipora, which aren't occurring in the late Silurian. That is a lovely example of a reef, and in about 200 meters, you can look at everything that is involved in a classic Paleozoic reef. Unfortunately, there used to be a motel there, and you could drive at the motel and get permission. Now I think a whole bunch of people have privatized it, so I'm not sure how accessible it is. It looks accessible on Google Maps. We're in Western Canada, so let's talk a few things that probably aren't hard to get to. So if you're driving out to Columbia ice fields, you might want to stop and think about Big Hill or the Big Bend, different ways of calling that thing, or grassy lakes. Most of you probably been above Canmore and looked at. If you want to know what a reef reservoir looks like, go there and watch out for all the climbers that don't put rocks down on you or fall down on you. And then this was the thing that I couldn't get into Reefs of Canada, but tried to. So let's look at them. Those are all why we worry about reefs and outcrop, because reefs can occur in salt-filled basins, which is what that one that I showed you from the Carboniferous in Nova Scotia. It went back to only being microbial because not too long after that, the Windsor salt completely buried the reef. But there are a number of places, Silurian reefs, ones in northern Alberta, the Devonian reefs, and in Saskatchewan, the Pagosis reefs, that all occur. They didn't occur with the salt, but they were in the salt basin after it completely dried up. And on its way to drying up, it's not fit for corals and sponges, but the microbes and the algae don't care, and they're still there for a while until they die out as well. There are times, and it's right about here, that you get a major die-off, and you have hardly any, but there are a few little patch reefs, even in the Wadman, which is actually in the upper part of the Devonian. I think the Devonian is the only unit. Most units, if you have a major change and a major extinction, it's that's how they, a bunch of fossils died out. And so if you want to make a break and stratify your geological column by the contained fossils, you want to come right after a major extinction event. This is I don't know what's so special about the Devonian, but it's weird that the major extinction event isn't at the end. It's actually within the middle of the upper Devonian. Anyway, there's lots of reefs in Canada of all kinds of different ages. And that's why I worry about them. As I said, probably how many people have been to the Grassy Lakes Reef? If you haven't been there and you want to know what a Leduc or any kind of reservoir in carbonates in Alberta looks like, that's where you want to go. And it has bugs. Some of them, they're big enough to put a bench in, and other of them, they're just big enough to mess you up when you're trying to core them. But the other thing that you can see at a distance, and you'll have to take my word for it. But if you, before you start driving up this road and then you park somewhere in here, you have to get permission, $15 to get a look at this stuff now. And you park and you hike, or you can go to the top and walk down to it. Stop and then turn around and just look at about that level, which is about where the Grassy Lakes are, about there in the wood. And you'd actually see the mounds of these patch reefs. They're light enough colored and they actually make a bump, and you can see the patch reefs before you go up and touch the reef. And if you stay on the road and go to the top of the road, this is what isn't in your article. I think Howard looked at this and said, nobody's going to know what this is all about. Let's say talk at length. And so I got a chance to talk at length. Should I be shutting up yet? No, I got enough time. Even in the Devonian, which is mostly coral and stromatophyte, just before the end of it, sort of at some level right in there, in the Nisku and the younger Winterburn units, you actually start getting evaporitic and restricted and not a very nice place to live. It's interesting. A bunch of these very large are called megalodont clams. This kind of thing, you can see them right there. That's in dolomite, but you can still see it there. And they kind of get a size where they're pretty good size. There's one in there. And you see these kind of layered algal thrombolytic type textures, or this kind of texture. Some of that's probably diagenetic, and that's some kind of break in the rock. If you get early cementation or even beach rock, you can get perfectly good rock that'll have perfectly good fractures and be like built yesterday, geologically speaking. So you see that sort of thing by the roadside. And here's what, well, I stuck in your picture there, Howard, of the Google Maps, the roadside, and I don't know why it isn't there, but I guess it isn't. The other thing is, if you're going to go out to the Columbia ice fields and show your visitors, because they're not going to the States anymore. So you're heading north. Sometimes they call this area Big Bend, and sometimes they call it the Big Hill, which is right there. And this is a safe place. If you go and look at the stuff above Canmore, be careful, because people go around that corner. It's a gravel road. It's dusty. I don't know. Some of them seem to think it's kind of a racetrack type effect. So don't get wiped out on the road. That's probably the most dangerous part of Reefs by the roadside visiting. There's a big parking area. It's quite safe to go in there and take a look at that. So, and what the reef platform or the carbonate bank is off to your right. And as you look at it, it fingers into the left and goes off reef, and it's going off reef into carbonate. So it's kind of hard to see, but there is a color difference. And if you look at it, I'm not sure I could get up there anymore, but there's interesting stuff to get up there too. But I don't know if you'd have to carry me up, but I'm willing to lead you if you're willing to carry me up. This is a diagram. So you're into the main part of the reef here. And if you go off here, you're going off reef off to your left. So anyway, there was a wonderful MSc. I think he won the prize there, Dale Dolphin, and Ed Cloven was his prof. I was actually, way back then, I was still on the thesis awards committee. Actually, no, that was a little bit before when I was on it. But anyway, he did a wonderful job. I thought he should have got a PhD for that effort, but he actually had, I know, do any mountain climbers here? No, you've got more sense than that. Good. And Dale had more sense of that too. He got people who were kind of keen on climbing, and that's like a cliff. They actually sampled by rope to get his fossils. And most of it's dolomite too, but as I say, if you have some preservation of dolomite, you can make a pretty good guess as to what it was. And you can see corals through the dolomite, and you might get to see mountain caribou and pretty scenery. So this is what I couldn't get into Reefs of Canada. And I'm really disappointed because, that's a beaver. And I'll argue, in fact, I don't have to argue. I just have to quote. No, I'm not making this up. I'm just reading what's in the they used to have real nice signs, and either they got stolen or they took them away because they were half stolen. So that's my son, who's now 55 or something, and he was 10 or 12 then. This was the sign there, and you can see the tree trunks that big in it. You can see the branches. Obviously, if you look at a present-day beaver dam, and it's been there for a while, you'll find all kinds of things growing on it, including willows and so on. And so you can actually see the willows preserved in the travertine and tufa. I tried to get it published in Reefs of Canada, and then I thought, well, I'll get slightly more scientific. My wife said be more scientific. So I did this cross section, and that didn't get it into the Bulletin of Canadian Petroleum Geology. I did talk Roy Krause. I actually talked Roy Krause into doing oxygen isotopes where you could actually figure out the temperature. Those tufas travertine were precipitated about 1 or 2 degrees centigrade. How more, if that isn't Canadian, I know what it is. And the other thing that's kind of fun about that is you get charophyte, and there are actually some lakes. I know what the chain lakes, what is down south of Okotoks and Black Diamond, or whatever used to be called Black Diamond now. There's a park there, and they're actually growing in the beach. They're not growing in that deposit now in the creek, but it's full of these charophyte stems. It's got ostracods. It's got all kinds of cavities from the tree trunks and so on. There you can see the branches of probably a willow or something like that. That's the log mold that you can actually see the knot holes and whatnot of it, probably pine. If you know something about carbonate reefs, you actually have botryoidal cements, which usually are, those are submarine cements, blah, blah, blah. Anyway, this isn't quite submarine, but it obviously was wet enough that was getting precipitated. And there's still stuff precipitating in that creek to this day. And anyway, a very Canadian reef, and I couldn't get it into Reefs of Canada. Terrible. Anyway, as I said, I'm going to donate a copy. I have 2 of them, so I got my own souvenir. What was funny is I'm going to give you a real quick run through about modern reefs. Now, we're too far north to get your corals and your sponges and shallow water reefs and your roulette. But we do have reefs, and they tend to be in deeper water. And guess what? They're sponges and corals anyway, but they tend not to be scleractinian or corals that have associated algae, which is one of the tricks that modern hexacorals and the reef-forming shallow water corals have, that they can precipitate quickly because they have associated algae. Those guys don't, and they're very slow growing. And if you've been following the wonderfulness of Canadian lumber versus American lumber, slow growing is good. You get strong and very tough wood. Guess what? If you have slow growing corals, that's the stuff that they make jewelry out of. But then you got to be a real good diver to get it, or do drags or something. But what is funny is this Canadian Reef Inventory Project, which ended up in that book by the Canadian Society of Petroleum Geology, Lori Cooper did a T-shirt for us. And so she got all these geologists all dressed up like Inuit, or maybe Inuit geologists, I don't know. And they're all looking underneath this layer of ice at these corals. Well, we actually had folks who were working out of Bedford Institute in the Arctic, on an Arctic island off Axel Heiberg. And guess what was underneath the ice? What they found underneath the ice was geodetic coral sponges. And this is kind of a summary of what you have that's making carbonate. I was the convener for Reefs of Canada. And if you know about the Mesozoic and the recent, I'm showing you how desperate I got, and I'll show you what I found out, or what anybody who had looked into it would find out. But you're not going to find corals and sponges and shallow water reefs. What you will find is seep deposits like black smokers, but you can actually get them from hydrocarbons, and that's what this one is. This is actually Christopher Shale, and there's a bunch of shell beds, and this was 1975. A chap by the name of Roy wrote an article about this. I'd actually spent a 1,900-hour day. There was no nights there. In fact, we worked at the nighttime because in the daytime it got too warm and you got fog. And you don't want to be left out with a helicopter not able to get you, because that happens a few times because of the fog. So we switched the time there. But he had this thing and he thought, well, I guess it's a shell bed, and this shale must have been shallow there. Well, 2 years later, the world started knowing about seep deposits. And they were the black smoker type seep deposits I just showed you. But you could also get them from hydrocarbons, and you can get them like some of the real primitive types of prokaryotes, the guys that don't even have nuclei in their cells. Some of them can live in hot water, some of them can live in hydrogen sulfide. It's amazing what they can live in. they found out about these things and said, so he didn't have an analog. Now we had an analog. And so in 1987, I could use something like that as an analog. And Benoit Beauchamp ended up writing all kinds of articles, and I ended up in et al. That's why it said something about et al. In there. So what can you get? That's a deep water sponge. Those are deep water corals. Those are seep deposits. There's oyster beds and so on. So I went and Googled up some stuff, and all that yellow is actually beds that have what they call sponge mounds or sponge grounds, and all that is sponge material, and all those yellow are where you find them off Labrador and off of Newfoundland, and I guess some of them off of Nova Scotia. And that actual hydro, that's Ellesmere, so actual hydro is over here underneath the ice. So if you think about snowball Earth or whatever you talk about in the just prior to the Ediacaran, if that can live underneath the ice, I guess you can kind of hang in there and live underneath the ice, even if it's all over the world. And don't worry, we're geologists, so they argue about whether it was all over the world. This is off of BC. You can see this is the map view of the sponge mound. There's a Sparker view of, there's the seafloor, and those are the mounds that are trapped by sponge. I actually went out to Sydney as a geological survey research area near Victoria, and I asked to see one of the cores of this that was taken right through one of these sponge mounds. And that is sort of how far apart, imagine the core is about, 2.5, 3, 4 inches. That's how far apart they are. If you don't squish those all down, it would be pretty hard, you see something like that, say, what is that? A reef? I don't know, it doesn't look very close together, but think of cornflakes all separated and then far enough apart, and I guess that's what you get. And what is kind of fun is, this is the Fraser Delta, Vancouver is just over here. And on top of some of these ridges, there's probably ice push ridges that probably have something to do with the glaciation. We actually have sponge mounds in front of deltas. And that was one of the arguments and one of the stories I have for my Jurassic reefs, because you get sponge mounds in the late Jurassic, as well as coral and the usual kinds of shallow water reefs. Anyway, there's some of the places where they've sampled, usually in kind of protected channels, that what they call the gully actually has a nice shell, found a salt dome with talc on top of it, full of gas and a little bit of oil underneath it. But it's now a protected marine area, so nothing will ever happen to it. I don't think it was big enough to probably develop, but there's what some of your corals look like in the deep water. Every once in a while, fishermen would be dragging, especially for scallop anyway, and they'd come up with corals and send them to Bedford and say, what is this stuff? But they've done more formal surveys, and they found some here in amongst all those sponge fields. So anyway, that's it. And I think I've actually stuck to my time. And questions?
When you're talking about dolomite, so I'm thinking of the dolomites in Italy, and then that it also produced some of the best marble that, say, Michelangelo used to report.
I can break up machines. Sorry about that. Let's get out of hook here for lobster machinery. Sorry about that.
Dolomite was so old and so compressed and made up of all this little tiny stuff that it became this really fine marble.
Well, I have to look into it, but I think most marble, in fact, is on the way to being metamorphic. And it's probably limestone, because actually limestone, nothing wrong with dolomite. Get back to me and correct me if I'm wrong. But one of the things that makes dolomite a great reservoir rock is it isn't very soluble once it gets changed to if you actually have a closed system, magnesium is smaller than calcium, so you actually, in theory, can actually make porosity just by changing limestone and dolomite. But most systems are closed in nature, so that's not a good reason. But it is brittle and it fractures better. And so when you have all these nice bugs, and the matrix may be fine between them, having the fractures connecting the bars is going to make all different. But if you're a sculptor, you don't want fractures. So that's why probably what difference is, you don't want to even worry about this kind of rock for sculpture, because it's too, it's not cemented up enough. What you want to do is get the metamorphic grade, In fact, there are even types of igneous rocks that are calcium rich, which I don't know the name of, but I don't know if they ever used it, but anyway, so that's right, you want to get your limestone very much compressed, get rid of all these holes. And then, because it doesn't fracture as much, you can deal with it and not mess up your sculpture, but you don't want to be doing an arm and it all falls off. I mean, the vandals will do that soon enough. The things that would make dolomite a big reservoir would make it a poor sculpture material. And the thing that make limestone, if you actually look at a graph of where the oil and gas in Alberta is, and I have a gadget like that, or a graph like that, if you look at it, what happens is you get deeper and deeper and deeper, you get less and less oil, you get more and more gas, and you get sour gas. And the other thing that happens, the only place that you actually get a lot of really good oil is the Swan Hills. And because that evaporates with it, and it's at 2,500 meters, and in most places now, where if you go to 2,500 meters, then you go to Dolomite Reservoir, then you hope you have sandstone reservoir, or you shoot yourself with your carbonate specialist because it has no holes in it. So you want to have a dome cut. The Swan Hills has sweet, oil. It has next to no hydrogen sulfide in it. And all that is telling you something about, in fact, someone said dolomite is an actual evaporite mineral. In some senses, it is. If you want to get shallow dolomite, you do it in a evaporative setting. And that's why probably that reef that I said, we're worried about the pretty rocks on top and not about the one per reef underneath. It's all dolomitized. And that probably was dolomitized very early in its history because you went from that and you think about when you're evaporating seawater, you're going to get a concentration of magnesium before you go to bringing up salt. And so you're going to dolomitize it early. A lot of other cases, and that's, they talk about reef detritus being a lot of fun, but if you talk about how the dolomites form, that's another geological conundrum that people argue about. Somebody, I think, has recently come up with a good story, but then I can't remember what the story was, but it convinced me, but what do I know? Anyway, but yeah, so that's probably, I was just doing a steady, I think I made an abstract that I said, I actually got a job, and my job was try to decide how to put carbon dioxide as a storage for carbon capture and storage in the very reefs that were producing methane in the Abenaki Formation. And unfortunately, the field actually lasted less time than it took me to get a PhD. It says a bad thing about that reservoir, but also the bad thing about Leslie, except that he was having a lot of fun. We're in Texas, and they didn't have a qualification that said part-time PhD student. But they said, well, you don't get it now, we'll kick you out. And so I got it, and I didn't get kicked out.